What if the universe is so unimaginably vast, with more stars than grains of sand on every beach on Earth, that the real question isn't whether alien life exists, but why we haven't heard from them yet? Think about it. Since 1977, NASA's Voyager 1 has been drifting through space, carrying a golden record, a literal mixtape of humanity, loaded with our music, our languages, our coordinates, just in case someone out there is listening. We sent a message into the cosmos, and the silence we've gotten back, that silence might be the most important puzzle in all of science. Hey, welcome back to Space Secrets, the channel where we take the biggest questions in the universe and break them down so clearly, you'll be explaining them at dinner tonight. I'm so glad you're here because today we're diving into 7 theories that seriously suggest aliens might actually be real, and some of these will completely rewire the way you think about our place in this universe. Stay with me all the way to the end, because the last theory, it's the one that keeps actual scientists up at night. And if this is your kind of content, big ideas, zero fluff, pure cosmic curiosity, hit that subscribe button and join the Astromat family. Let's get into it. Imagine you're standing in the middle of the Mojave Desert at night. No city lights, no noise, just you and an endless sky packed wall to wall with stars. Now imagine that every single one of those stars is a sun, and around many of those suns, planets are orbiting right now tonight, some of them older than our own Earth by billions of years. That's not science fiction. That's the universe we actually live in. Our Milky Way galaxy alone contains somewhere between 200 and 400 billion stars. And beyond our galaxy, there are at least 2 trillion more galaxies in the observable universe. 2 trillion. If you counted one galaxy per second without stopping, it would take you longer than the entire age of the universe just to finish the list. So here's the question that stopped one of the greatest scientific minds of the 20th century dead in his tracks at a lunchroom in Los Alamos, New Mexico, back in 1950. A physicist named Enrico Fermi, sitting with colleagues, chatting casually about the possibility of alien life, suddenly went quiet, and then asked something so simple it was almost embarrassing. He said, "Where is everybody? That's it. That's the whole paradox. Given a universe this enormous, this ancient, 13.8 billion years old, and filled with the same chemistry that built us, the math says civilizations should be everywhere. They should have had billions of years head start on us. They should have colonized galaxies, sent signals, left some kind of mark on the cosmos. And yet, complete silence. NASA's SETI programs have been scanning the sky for decades. The Allen Telescope Array in California has searched millions of radio frequencies. We've picked up strange signals, including the famous WOW signal in 1977, which lasted 72 seconds and has never been explained or repeated. The universe is screaming with possibility, and whispering back nothing. That gap, between what the math says should exist and what we actually detect, is called the Fermi Paradox, and it is arguably the most important unanswered question in all of space science today. Now, some scientists think they've found a way to actually calculate the odds, and it starts with a deceptively simple equation that changed astronomy forever. So if the universe is this staggeringly vast and the silence is this loud, maybe what we need isn't just wonder. Maybe what we need is math. In 1961, a young American astronomer named Frank Drake stood up at a conference in Green Bank, West Virginia, the first ever scientific meeting dedicated entirely to the search for extraterrestrial intelligence, and wrote an equation on a chalkboard that would change the way humanity thinks about its place in the cosmos forever. It's called the Drake equation, and here's the beautiful thing about it. It doesn't give you one answer. It gives you a framework for thinking, a way of breaking an overwhelming question, are we alone, into smaller, more manageable pieces. Think of it like planning a road trip across America. You don't just ask, can I make it? You break it down. How many miles? What's my gas mileage? How many stops? Each variable narrows the question until the answer starts to take shape. Drake did the same thing with the cosmos. He asked, how many stars are forming in our galaxy each year? Of those stars, how many have planets? Of those planets, how many could support life? How many actually develop life? How many of those civilizations become intelligent? How many try to communicate? And how long do they survive long enough to be heard? Multiply those variables together and you get an estimate. A rough, honest, genuinely uncertain estimate of how many communicating civilizations might exist in the Milky Way right now. When Drake and his colleagues ran the numbers that day in West Virginia, they got a range somewhere between 1,000 and 100 million active civilizations in our galaxy alone. One galaxy, our galaxy. Now, the honest truth is that some of those variables are still wide open. We're still debating them today at institutions like the SETI Institute in Mountain View, California, and at NASA's astrobiology program. Because here's the catch. The Drake equation is only as good as the numbers you feed it, and some of those numbers we simply don't know yet. But what NASA has been doing for decades, quietly, systematically, and with breathtaking precision, is going out into the universe and actually measuring those variables, one mission at a time. And what they've found might be the most important set of science facts in human history. Think about the last time you walked into a room and immediately knew someone had just been cooking. You didn't see the food. You didn't see the stove. But the chemistry in the air told you everything you needed to know. Garlic, maybe, or fresh coffee, or something baking in the oven. Your nose read the invisible fingerprint of what happened in that room. That is almost exactly how NASA searches for alien life across the universe. It's called biosignature detection, and it is one of the most exciting frontiers in modern space science. The idea is elegant. Life doesn't just exist. It changes its environment. It exhales. It metabolizes. It leaves chemical traces in the atmosphere of whatever world it calls home. And those traces, those molecular fingerprints, can be detected from billions of miles away if you have the right instrument. Enter the James Webb Space Telescope, NASA's $10 billion marvel, launched on Christmas Day 2021, now positioned nearly 1 million miles from Earth. Webb doesn't just take pretty pictures of the universe. It reads light. When starlight passes through the atmosphere of a distant exoplanet, different molecules absorb different wavelengths of that light. Webb can decode that pattern and tell us what that alien sky is made of. What are scientists looking for specifically? Oxygen, methane, carbon dioxide, water vapor, ozone, and most intriguingly, a combination of gases that shouldn't coexist naturally. Because on Earth, the only reason oxygen and methane stay in our atmosphere simultaneously is because life keeps replenishing them. Without biology, they'd cancel each other out within centuries. At the same time, NASA's Mars Perseverance rover is crawling across the Jezero crater right now, a place scientists believe was once a lake billions of years ago, collecting rock samples and scanning for ancient organic chemistry. Not little green men, not flying saucers, just the quiet, patient, undeniable chemical whisper of something that was once alive. This is real. This is happening right now. And the extraordinary thing is that we're not just guessing anymore. We're measuring. But here's what makes scientists even more optimistic about finding life. And it's not on a distant exoplanet millions of light years away. It's right here, hiding in our own cosmic backyard, beneath miles of ancient ice. For most of human history, we assumed that life needed exactly what we have here on Earth: warm sunshine, liquid water on the surface, a comfortable distance from a stable star. We basically used our own neighborhood as the only template for what a living world could look like. And then we started looking closer, and everything we thought we knew got a whole lot more interesting. Here's a thought experiment. Imagine you're deep in the ocean, miles below the surface where no sunlight has ever reached. Complete darkness, crushing pressure, freezing cold. By every measure we used to use, that environment should be completely dead. And yet, down there on the floor of the Pacific Ocean, scientists have discovered entire ecosystems thriving around hydrothermal vents. Tube worms, crabs, shrimp, bacteria that eat sulfur and breathe chemicals instead of sunlight. Life, finding a way in conditions we once considered impossible. Now take that discovery and point it at Jupiter's moon Europa. Europa is roughly the size of our own moon, but beneath its cracked, frozen surface lies a liquid water ocean that contains more water than all of Earth's oceans combined. More water. On a moon. Orbiting Jupiter. And the heat driving that ocean doesn't come from a sun. It comes from the gravitational tug of Jupiter itself, flexing Europa's core like a stress ball, generating warmth from the inside out. NASA's Europa Clipper mission, launched in October 2024, is on its way there right now. Its job is to
Atlantis now
fly
beginning
by
what is known
Europa
as the
dozens of times,
pre-flare
scanning
maneuver.
that
We'll
ice
pull the
shell,
nose up a little
measuring
bit
the
right
ocean
before it
beneath,
hits the
and
runway.
searching for the exact same chemical conditions
Its
that
speed now
support life at the
320
bottom
miles
of
per
our own
hour.
Pacific. And Europa isn't. Saturn's moon Enceladus is actively venting
Gears
water
down
vapor
and
and
locked.
organic molecules, carbon, hydrogen, nitrogen, oxygen, directly into space through geysers at its south pole. NASA's Cassini
Main gear
spacecraft
touchdown.
flew right through those plumes and
Atlantis'
tasted
nose
them,
being now
the
rotated down
ingredients for
toward the
life,
runway.
shooting
The
into
chute
space
being
like
deployed.
a cosmic fountain. When we widened our definition of where life could survive, the solar system went from feeling empty to feeling almost crowded with possibility. But even with all of this evidence building up, there's one final theory that reframes everything. And it asks not just whether aliens exist, but whether the universe itself has been quietly filtering which civilizations get to survive long enough to find each other. So here's where the story takes a turn. A fascinating, slightly unsettling, genuinely important turn. We've established that the universe is ancient and enormous. We've shown that the math suggests civilizations should exist. We've seen that the chemistry of life appears almost everywhere we look, and yet the silence persists. No confirmed signals, no verified visitors, no cosmic neighbors knocking on our door. So either we are spectacularly, improbably alone, or something is stopping civilizations from reaching the point where we could detect them. That something has a name. Scientists call it the Great Filter. Think of it like the most brutal audition process in the history of existence. The universe throws challenge after challenge at every world that tries to produce intelligent, spacefaring life. And somewhere along that journey, almost every contestant gets eliminated. The Great Filter is the stage almost nobody passes. The question that keeps astrobiologists and cosmologists at places like NASA's Astrobiology Institute and Harvard's Astronomy Department awake at night is devastatingly simple. Where is that filter? Is it behind us? Or is it still ahead? If the filter is behind us, we got lucky. Maybe the leap from simple chemistry to the first living cell is so astronomically unlikely that it almost never happens. Maybe the jump from single-celled life to complex organisms is the bottleneck. Maybe the evolution of human-level intelligence is a 1 in a trillion cosmic accident. If any of those are true, then we passed the filter already. We are the miracle, and the universe's silence makes complete sense. But here's the part that sobers every room it's presented in. What if the filter is ahead of us? What if civilizations routinely reach exactly our level, curious, technological, reachable, and then something ends them? A self-inflicted catastrophe. A technology they couldn't control. A climate they couldn't stabilize. An asteroid they didn't see coming in time. This is why some of the world's leading scientists, including those advising NASA's planetary defense programs, treat the search for extraterrestrial life with a strange mix of hope and caution. Because if we point the James Webb Space Telescope at a distant Earth-like world tomorrow and find clear, undeniable biosignatures of complex life, that discovery, as thrilling as it would be, might also be a warning. It would mean life gets this far regularly, and something, somewhere, is still waiting to filter it out. Now that we've journeyed from the Fermi Paradox all the way to the Great Filter, let's bring it all together. Because the 7 theories we've covered today don't just suggest aliens might be real, they fundamentally reshape what it means to be alive and aware in a universe this vast and this silent. So let's land this spacecraft. Today we traveled from a lunchroom question in New Mexico all the way to the edge of what humanity might become. And the journey covered some of the most profound territory in all of space exploration. Here's what we actually learned today. First, the universe is not just big. It is statistically, mathematically, almost unreasonably full of the conditions that produce life. From Frank Drake's equation to the James Webb Space Telescope reading the chemical fingerprints of distant worlds, the science keeps pointing in the same direction. The ingredients are everywhere. Second, life doesn't need our moons. Europa's hidden ocean, Enceladus shooting organic molecules into space, hydrothermal vents thriving in total darkness at the bottom of our own oceans. Every time we expand our the universe hands us a new candidate. NASA's Europa Clipper is on its way right now, and what it finds could rewrite every textbook on Earth. Third, the Great Filter is real, it is serious, and whether it sits behind us or ahead of us is arguably the most important science question our civilization has ever faced. Because the answer changes everything about how we should treat this planet, this moment, and this window of time we currently occupy. And here is the thought I want to leave you with tonight. Every NASA mission we send out, every telescope we point at the sky, every rover we land on a distant world, is humanity refusing to accept the silence. It is 8 billion people on a small rock, collectively leaning forward into the dark and whispering, "We know you're out there. We're still looking." And maybe that impulse, that refusal to stop asking, is itself what makes us rare. Not our technology, not our biology, but our curiosity. The fact that we look up at all. In a universe that has been running for 13.8 billion years, we have been asking these questions for maybe a few hundred. We are extraordinarily early. The greatest universe mysteries, the deepest space discoveries, the most transformative moments in human scientific history, they are almost certainly still ahead of us. And that is not a reason for anxiety. That is the most exciting science fact of our entire existence. If today's video left you seeing the cosmos a little differently, that's exactly what Astromat is here for. Hit that subscribe button and join a community of people who believe that understanding the universe is one of the most worthwhile things a human being can do with their time. New videos drop every single week. Space exploration, physics explained, universe mysteries broken down clearly, without the jargon, with all of the wonder. I'll see you in the next one. Keep looking up. Hey, thank you so much for watching this one all the way through. It genuinely means a lot. The fact that you now understand something like the Great Filter and why it matters not just for science but for how we think about our own future as a civilization. That's exactly the kind of idea that sticks with you. And with NASA pushing deeper into our solar system every single year, these questions are only going to get more real and more urgent. Honestly, this is my favorite kind of science to dig into with you. The stuff that starts with a simple question and ends with your entire perspective shifted. I'll see you in the next one.